Deputy Vice-Chancellor, may I present to you the winner for Teacher of the Year for the Department of Engineering, Design and Mathematics, Tushar Deval.
Hello everybody, today we're going to try and wrap our head around this immense minefield of number of holes that are available on the machine elements market. Really, if you can see on the screen, there is a variety of these. There are countersunk, counterbore, there's a straight one, and all of this then depends on the project at hand. Obviously, Solidworks being such a cute software, it allows you to make all that selection beforehand, so you don't need to worry too much. And designing for these holes and designing for these fasteners is really easy. Okay, so let's take a look. I'm going to start with a new part file. Here on the top plane, I'm going to sketch a billet. Which is obviously some random numbers, and I can extrude that out to create a solid. Okay, now let's just say for some intents and purposes, I wish to drill a hole here. Instinctively, I want to go into the Extrude Cut. I want to click on that plane, draw a circle, go into Extrude Cut and drill that hole out. However, that's not the right way, okay? From now onwards, if you are drilling holes for fitting fasteners through, or if you want to throw this into assembly and this then goes on to something else, or there's another part that fits on top of this, etc., it's a good idea to use something that's called Hole Wizard, okay? This allows you to pick a hole from a standard. There are so many standard ones, and there are so many other custom made ones as well. You can pick any of these, and all you got to do is select the type of that and select the position, and then SolidWorks will go away, do all the work, and come back with an industry standard hole for you. Okay, now let's just say for the sake of this demonstration, I want to drill a counterbore hole. So I'm going to select the first option right there. The difference is obvious between counterbore and countersink. I am going to pick myself a standard, which is BSI. This is fine. I'm okay with that. And down here, it allows me to pick the diameter. So M is metric, 20 is the nominal diameter of the hole here. So I'm going to go with M20, normal fit. And this is the end condition. So you could say blind, and you can specify a distance. So you could say don't go all the way through, probably stop in between somewhere, whatever that number is, you get to pop that number in there. And I think that's almost everything you want to say in this dialog box. Okay, next up, I'm going to head over to the positions bar, and when I do that, SolidWorks expects me to click somewhere to be able to start drilling. It's literally that. Okay, so at this point in time, I could select that flat face, and I will get holes which are heading that way, or I could select this radial face, and I will start to create holes which are radial, so they're all they're all pointing towards the center point of that curve. Or I could select this face here and start drilling there. Okay, so for this purpose, I'm going to go select the top plane there, or the top surface. And SolidWorks has brought us into auto. I didn't do anything magical here. All I did is select the flat surface there, and SolidWorks will bring us into the sketch menu, where we are now adding a point. What this allows us to do is wherever I drop the point now, it's going to drill that hole of that shape. Now I can't see properly from here, but what I'm going to do is use my best judgment and probably drop one there, and I wanted one on the origin, so maybe I could, I don't like this. So what I'm going to do is probably just leave that there. Okay, I wanted that to snap onto the origin. I probably want that snapping onto the center point of that circle, really. What I'm going to do is take control. Okay, can I look straight at it? Yes, I can. Right, now we're still in the sketching environment. I'm not drawing any points anymore, and I can, if I wanted to, I can use the dimensioning command, or I could use the geometric constraint to say this center point, holding down control, is coincident with the origin. I could do that. That works really well for me. I can green tick to confirm, and I can say, how about this center point coinciding with that semicircle. And I think this is what I wanted. They are fully defined now because they are latching onto something which is a definite entity in my sketching area. And this is what I'm about to commit to. I'm going to go green tick to confirm. And it was as easy as that, really. Let's have a look on the inside. We managed to create these. Once again, these are industry standard, so if you were to go out and buy yourself M20, it will fit through here quite nicely, and that is 60 deep, really. So all of this, you don't need to worry about making sure this angle is correct, making sure that depth is correct, making sure that gap, none of that. It's all programmed in. All you got to do is click on the right icon and click on the right plane where you want to drill. Okay, obviously you did make some selections about what kind of fastener you would like to fit in, and Solidworks will remember that when we go into assembly, all of this is then into the system. There is an icon in assembly you can click which will auto populate all the fasteners because you as a designer made that choice now in the design stage. And I think it's pretty funky, because if I were to do this manually, it will take me a long time to sit there drawing that profile, probably using the revolve cut command to be able to revolve that out 360, and even after that it probably won't be guaranteed that I'll do a good job. Okay, so I love using hole wizard whenever I have the opportunity. Once again, if you look on the tree, you can see that little entry there that says counter bore for M20 hex. I can go in and I can change that. Look at that. I didn't make any of that sketching. All I did is I used the hole wizard and it just did it for me. That's why it's called a wizard. If I wanted to change any of the details, I could probably go back in and edit this as standard. So I'm going to go in there and say, look, 60 is not enough. I want to push it slightly higher or slightly deeper. So I'm going to go bump that to 70, and SolidWorks will do its thing. And it has remodeled that to comply with our new decision. And this is pretty much it. What I want to do is probably drill one more hole around here. This time I would like to make it into a countersink one. This is my favorite kind. Once again, you can scroll down. You can make sure you're picking the right. There are so many standards in here to work through, and whichever one you want to work with, it will depend on that. Your options will get fewer, or you will get more options given further down the line. This time I would like to go all the way through like so. And in positions, I'm going to go over to this flat surface here, and there we have it. I'm trying to drill a hole here. I wanted that to be concentric with the edge, so I'm going to go probably do that. Can I do that? Yes, I can. And I can green tick to confirm, and that has given a concentric hole right there at that point. And that's a very standard countersunk M10 for us. So from here on, you need to remember the fact that if you're planning on running a fastener through it, if the hole is there for a mechanical connection purpose, definitely use a hole wizard, and don't use Extrude Cut or a revolve cut. This is going to create extra work for you if you did any of that. And this, however, all the seconds I invested here, I'm going to reap the benefits by the time I throw this into assembly. SolidWorks knows all the decisions are made in terms of the fasteners, etc. So I don't need to think about that ever again. Okay. And once again, editing this is just as easy as editing any other command. Okay. In the next part, we will try and invest this to try and create something meaningful that we all can relate to. Okay. Next up, I'm going to show you something that's really cool. I think I can say that about everything I show you in SolidWorks. Here, I'm going to show you how you can create a part which is driven by variables. This is just a small little process where you create global variables which then allow you almost a Microsoft Excel like control over the model you're creating. Okay, so let's just say here I want to sketch this rectangle here. Now what I want to do is I want to dimension this as my length, if I may. There we go. And this is my width. Now one might argue there is nothing special I did around here. Everything, it's a fairly straightforward standard process so far. What I can do at this point in time, I can double click on this dimension and I can say this equals to, when that is in edit mode, equals to, I can say length, length, and there's a message that says, are you sure you want to create a new global variable? I'm going to go and say yes. That's beautiful. I'm going to green tick to confirm. Nice. The dimension changes to indicate that there is an equation, there is a variable behind that number, and I'm going to bear that in mind. I can do exactly the same around here where I can say this number is equal to width, and SolidWorks will once again warn you that you are going to create a new global variable. I'm going to go ahead and say yes. That's exactly the purpose of this demonstration. Green tick to confirm. Right, okay, so we have those two numbers. They are then matched up against a variable, which is length and width. You kind of know where I'm going with this, you know. I can use those variables to probably dictate the height of this, you know. So what if I wanted to specify the height actually depends on the length every single time? You know, I can create a dependent geometry. I can say what if the height is 80 per, I could, this is a standard approach. You can go and say, well, that's that, green tick to confirm. Okay, but I didn't want that. What if I wanted this equals to, and I can pick a global variable, and I can say every time the height needs to be 80% of the length. That's reasonable. Green tick to confirm. And SolidWorks has gone away, solved that math, and it's come back with a number which is visible if I did this. There we go. So that 200 was a derived number. I didn't draw that up. I wonder if I can make it stay, show feature dimensions. So wait, there we go. That's 200. I set that to be 80% of the length, and that's also width, which I don't think I use that dimension anywhere. But this is the beautiful part of this. You get given a new folder that's called equation, and this equation here, anybody who is probably not trained on SolidWorks, they can come down and they can edit this this box, you know. This is pretty much like Microsoft Excel. So let's just say you're working in a company and somebody takes a phone call and the customer says, can you manufacture me something that's 250 by 150? Automatically it will be all modeled within SolidWorks, and you can send print and this will be machined automatically. Okay, clearly the height of this object depends on the length of it, the way we set it up. And I could right click and I could go manage equations, and here I change the numbers. Here I can control it, so I can say I wanted that to be 200 now, and I wanted this number to be, just to change the aspect of it a little bit, and it will go ahead and run those changes through to be able to give us a completely different body. Once again, the height remains 0.8 of the length, which in this case but you get the rhythm. You know what's going on here. Okay, so this is what I call is creating variables, linking them up. There's also a way of getting Microsoft Excel to talk to SolidWorks. So you could be running some complicated maths, and some equations could be dictating a variable you need to bring in. And you want that to be a dynamic relationship every time you run the Microsoft Excel or MATLAB, probably for that regard, because you can connect MATLAB to Excel and now Excel to SolidWorks. And you could actively read the cell value to be able to change your object and be organic. I'm going to go ahead and show you an example where we can probably use this methodology to plan something out. I think this is really exciting. Now, I wonder whether those two things we looked at earlier, number one is how to use a whole wizard, and second one is how to create variables and how to use variables to create a dependent relationship within a part body. Whether we can actually try and model these hinges. Now, I love these hinges. They are so simple yet humble. They're very popular, very common, easiest piece of machinery you would see. And they kind of work. Everybody knows what the hinges do. I'm on about these straight hinges here. There is a variation in that, which is you might see different lengths. That's about it, really. And there can't be anything more. Okay, they generally come in three parts. You got the male and the female, depending on which way you're looking, and there's a pin that keeps it all together. Also very similar in this example. So what I would like to do right now is to model this hinge as much as I can, and see whether we can incorporate some of those fundamentals we talked about previously. Over in SolidWorks, I would like to show you a slight variation of what we've been doing all along. Okay, you know how every time I said you need to create a closed compound to be able to extrude? Well, not necessarily. Here I can, on this particular plane, what I would like to do is draw this. Okay, it's not a very specific geometry. I'm gonna very roughly sketch this. Completely random numbers. I would like that line to come out like this, probably this far, and I would like that line to end a certain distance away, probably 100, like so. And there's a bit of forward thinking going on. What I would like to do is draw myself a construction line that goes 45 degrees, a random length. It doesn't need to be going anywhere as long as it allows me to do this. Trim. I don't need that bit there, and I don't need this bit here as well. And green tick to confirm. What I'm going to do is blend the circle with the line now. So I get that. 10 mil radius is good. The numbers are completely random, and I like this profile. Okay, all I did here, just to summarize, I created a circle, a straight line, and I trimmed away the area I didn't need, and I blended both of those together to create a wire shape, a hook shape like this. Okay, now what I want SolidWorks to do is extrude that out for me. Now you're thinking, this is not a closed compound. How will it? Well, it will work. It will work. Right. So when that's pre-selected, I'm going to go into Extrude Boss Space. Every time you feed SolidWorks an open profile, SolidWorks will try and create a thin feature. Okay, that's a technical term, thin feature. It doesn't have to be a very thin feature. You could apply a certain thickness. Now all I did is I clicked into Extrude Boss Base. SolidWorks threw no complaints at me, and it just, like a puppy, trying to create a solid based on the sketch I had provided. What's going on here then? So the first part is very familiar. So we have the initial condition here that says from sketch plane. I'm going to go and say that's correct. Direction here, my favorite, is the mid plane, and this 10 is the thickness, this extent right here. So I want that thickness to be probably 150. Yeah, we'll see. I can come back and change that. Okay, around here, this is the new bit. This is where SolidWorks is trying to create a thin feature, and I can choose the direction. This right here is, if you remember that hook symbol we produced, it's getting a sense whether we step up or below or both side or mid plane, So I'm going to go and say, how about staying mid plane and creating a probably 5mm thick hinge. So that 5mm is actually this thickness here. So that's all we're trying to do here. We produced a hook shape there. We said that hook is 5mm thick and it goes that way 150, all standard process. Now let's just say it does look slightly exaggerated, but I'm going to go with that. Green tick to confirm. Now then, I'm going to apply a couple of fillets to round off the sharp corner here. So I'm going to go and say, how about rounding off this edge here, and then let's see if Solidworks gives me something reasonable. I don't think I want those edges, so I think I probably want that package. So I'm going to go and say, yes please, all 4 of them. That's the right thing for me to do. And this is what I have created so far. It's like you're working with a sheet metal, and you have created this part, this solid, out of flexible material, but it's not flexible anymore because you have stiffened it in that direction. You could, if you wanted to, you could save this as a hinge blank file. So this is just a blank. It's not a male part or a female part. It doesn't have any holes on it. This is, imagine if you're working on a conveyor belt and the machine is spitting out these, and then somebody hands them over to a cutting device that then slots in the middle or cuts out the end bits, and then it goes forward where it's we get some holes drilled onto it. Really, the process is going to be slightly more complicated than that. However, you can imagine that these are the blanks now. Okay, I've saved that as a blank one. I'm going to go ahead and process this a little bit more. At this point in time, probably I would like to maybe come up with 4 holes, so probably one round there, another one round there. I want to spread them out like this just to, constrain the hinge quite uniformly. You don't want the holes lying here because then you're going to have a slight lift off, You don't want that. So you want it to be constrained quite nicely. So probably 2 round here and 2 round there. Let's see if you can use the hole visit command. In there, hinges will generally have a countersink hole type, as you can see, for all the good reasons. You want the screw head to be hidden away and not interfere with the hinging mechanism. So I'm going to go activate the countersink. They all look fairly standard to me, so I'm going to go with the flathead, and probably M10 is my preferred choice. End condition doesn't matter because all we want is that. Through all is also good, and in positions, when I activate that, I'm going to go say, how about I have something round here. Ooh, there we go. We're creating holes now. I could do that, probably 2 that way and then maybe 1 that way, but this, how crude this is. I mean, I wanted them to be on the straight line. Probably I didn't get that. I got that in straight line, but there's just no relationship whatsoever. Also, I want to be able to control how far out that is from there, and I probably want to maintain that distance there and there. And maybe I want to make that distance based on the overall length of the hinge. And probably I want to make that decision there based on the overall width of the hinge. And I think I want to go back and maybe make some changes in the system because I'm not happy with this right now. So I'm going to leave this right now. Okay, I want to go back in the past and probably incorporate or use some of those global variables or create new global variables to be able to come up with those numbers, link them up so that I can use them at this stage. Okay, I'm going to go in my sketch. And I'm going to say this is a new variable called width. I'm going to create a new global variable. Press enter. Press enter again just to make it go away. And I'm going to exit the sketch. Here, where that's 150, I'm going to go double click that and say, how about I make that into a new global variable called length. So we have that. We have set it up as that is 100 and this is 150 length and width. Okay, fine. We are in good shape now. I'm going to rebuild that just in case because the traffic light symbol come up. If I wanted to, just in case you're wondering, I could control those key dimensions from here straight away. Okay, and that just changes everything for me quite nicely. Right then, what I want to do is I want to go and create those holes, and SolidWorks have remembered my choices because it generally does. And I'm going to go in positions, say how about having some holes around here like so. And that's pretty good. I'm going to say that's handy. However, I want to be able to control where they're sitting. Okay, now I'm going to press escape once just to get out of that, and I'm going to look straight at it. This is good. Right, now then, I want to say, and this is completely random by the way, I want to say this dimension here is 20% of the length. Or 0.2 times the length. That looks slightly high. I'm gonna roll back on that. What does 0.1 look like? That's pretty good. The number I'm after is 0.15 then. That is a good compromise. I'm gonna go green tick to confirm. And that has automatically worked that out. Remember what happens if somebody were to change the length of it, that changes alongside the length automatically. So it's not going to morph out of proportion. It's going to stay in scale. Okay. Now, if I were to go and say exactly the same thing around here, I didn't want that number. I wanted the other number. Let's go back into smart dimensioning from there to this edge here. And once again, I would like that to be times 0.15. And that does the trick. And confirm that. And that is a linked value right there. Okay. Here, I want to do something similar. I'm going to, well, there are a couple of things. Number one, I have made sure that this distance is secured. I haven't defined that yet. So we'll do that in a minute. Probably let's just take care of these two little holes here. I'm going to go and say this number here is equal to it's a proportion of the entire width. So about that looks correct to me. And here I can be sensible and I say I don't need to repeat that. So I'm going to go and I'm going to make it a line. So that does that for me. Okay. Now then, I want to say, how about specifying how far out that is from this edge here, just like this dimension here. Let's do that now. And then we got to do exactly the same for these two. Now this can be anything. So I'm just trying to come up with a logic. I can say that is width times, or you could just subtract width. You could reduce, it doesn't have to be a multiplication factor. You could reduce a let's just say this distance here, and you can always have a constant coming out of it. I'm going to go with width times 0.5 to start with. Let's see what that gives us. That's more appropriate, I would say. Green tick to confirm. And once again, I'll make sure these are linked vertically. So they sit vertically under each other. So I'm going to make sure they are vertical, which I have done now. Right, the only thing that remaining to do is for us to specify distance between these two. So you could do one of the other, or I'm going to go and say I'm going to specify how far out that is from this edge here. I'm going to say by doing this. And that's also a proportion of the length. Length times that is pretty good. I wanted that to be mirror across on the other side, so I can use a mirror function. I could draw a center line, I could replicate everything on the other side if I wanted to. I'm going to go ahead, because this demonstration is about creating and using variables. I'm going to carry on with that, and I'm going to say this circle or this center point is dependent on the length, like so. Green tick to confirm, and I think everything is fully defined. Now I'm going to go green tick again and green tick to come out of the whole wizard. There we have it. So we have created our first true blank, which is quite nicely controlled. I wonder if I can display annotations. There we go. Look what we've done. So all of these numbers, they obviously make it look really exciting. We know there's loads going on here, and all of these values are linked. And what I would like to do is now save this as a true blank. Okay, so that is saved. I want to test my logic. I want to see what happens if I change these numbers, and I want to see whether the holes move along with them. Some of them will function correctly. I'm pretty sure my logic is flawed at times. But we know there's only one way to find out. So I'm going to go into manage equations, and instead of 100 I'm going to go 150, and instead of 150 I'm going to go 250 here, and I want to see whether our hinge stays or breaks. Okay, well it's there, it's expanded. Okay, it didn't break, so this is good. I like this. This is not bad at all. Okay, so we have our blank here, which I have now saved. I have tested the logic, it works, it grows and shrinks, and the holes move accordingly, and they maintain the position. I'm really happy with this particular approach. What I would like to do now is to go ahead and make this into a female part, and I'm going to create a copy of that, and I'll work on that to make it into a male part. So this is obviously something new. We haven't done this before. We want to work with multi-body parts. Now this is within one part file. We are going to have multiple solids. Okay. What I would like to do is replicate this here in this space, so I could treat both of them equally, and I could reduce one and I could add to the other. That's my plan right there. Okay. For that purpose, I think I need a plane, so that I could literally mirror that onto the other side. Change that distance, probably like so. And I'm going to green tick to confirm. What I want to do is to create a copy of this on the other side. I'm going to go into the mirror function, and there are multiple options within here. I'm not trying to replicate the features. I'm not trying to replicate the faces. It is the body, the entire body I want to try and mirror across. Okay. My mirror plane is plane 1, which is pre-selected already. I don't need to worry about that. I'm going to go select bodies to mirror. I'm going to select that. Okay, I can't obviously merge them together because they are independent parts, so I should untick merge solids option, and I'm going to go green tick to confirm, and this gives me two solid bodies in my graphics area. Okay, and I can treat them, as I said before, this part here is derived from this one here. I could treat them equally now, so I could reduce one and I could add material here, or I could remove these parts here. It's quite nice to be able to look at both of them. In the end, once we're done, we can send them out in separate part files anyway, to be able to bring them into assembly to create that that motion. Okay, now then, what I would like to do is probably take a big chunk of material from here, and for that purpose I'm going to do the good old jumping onto that top plane, drawing a sketch and biting away the material that we don't need. So for that I'm going to say, how about, let's see if this works. I'm not really worried about that dimension there because that kind of goes up to there. What I would like to do is specify this. I want that to be 50%, so a quarter there and quarter there. So I'm going to go and say equals to length divided by 2. Let's see if that works. Length divided by 2. There we go. Beautiful stuff. Green tick to confirm. That's 75. Right, exit the sketch. Can I use that newly drawn rectangle to reduce or to take away the material from here? I can. Look at that. But there is a process because we don't really have just one part anymore. We got two of them within the part file. So I'm going to go and extrude cut it. Okay. Solidworks is asking what do you want to do. I'm going to go select my sketch, and it will try, and if I did it without thinking, it will remove material from both the bodies. I don't want that. Okay, it's gonna do this. I don't want that. I don't want that. You know, what I need for it to do is to remove material from this body only. So I'm gonna go into Extrude Cut. I'm gonna go mid plane, and at the very bottom where it says feature scope, I'm going to go not all the bodies, not selected body auto select. I'm going to go select them. I would like to operate that onto this body only. So when that is active, I'm going to go select that and say just operate on that, please. Green tick to confirm, and it shall take away the chunk of material from that hinge alone. Now this is getting better. Now what I want to do is remove the complementary sides so that they snap together quite nicely. All right, let's see if we can do that now. Once again, I'm going to jump onto this plane here. I wonder if I can use some of the existing relations. So I could, if I wanted to draw a rectangle. I'm going to go do this. I don't need to worry about dimensions because I think they're all connected, locked in like that. Exit the sketch. And I wonder if I can use that to take away mid plane. Yeah, mid plane is correct. And where it says auto select, I would like to select only this part. And green tick to confirm. Hopefully that'll clear that off. Quite nicely done. And I can finally mirror the feature. It's cut, and my mirror face is going to be the front plane because that's nicely centered, isn't it? And I'm going to remove that bit out using the mirror function. That gives me that. Now I think this is a great setup what we have here. Okay, what I managed to create is a male and a female in one part. We haven't done any assemblies yet, but in the next part you will see how we can bring this all together and make it articulating as well, so they will function together. What I have done here is I have created a linked part. So that's the benefit of having both of these in the same modeling environment. So we can say, actually, we're losing that from there, right? So let's make sure they fit. All of this is done in good faith, okay? And the last step would be to throw them out as a new part file, which I'll show you in a minute. What we can do, what we have done here is we have also linked all of these dimensions with the nature of the hinge, which is the width and the height of it, you know, or width or length of the hinge. So if the hinges come in different dimensions, you could just say, look, 100 by 200 hinge will look like this. And, you know, it's the process kind of somewhat automates itself. This is just a replica of that to start with, and then we carry on making some changes. In order to be able to save this as a separate file, which for assembly purposes you will have to, I can do this. I can right click from the solid bodies folder. I can right click and I can introduce that into a new part file, which then allows me to save that particular file as a male or a female hinge. So I'm going to go and say, save this as, I'm going to call that part B. And this is the beauty of these linked files, which is connected to the parent file here. Okay, so these are, I call them the derived parts or the children parts. Looking back on the parent one, if I were to make any changes to this, let me save this as well. That's saved. So if I save this as a new part file, green tick to confirm, there might be a little error that pops up. I'm going to say yes to that. And the file name I'm going to go with is called, that was correct, doesn't matter, save that. Right, so that's part A and part B. Okay, right, so what I have here is this is our master file. Okay, everything, all the decisions were made around here. However, when it comes to manufacturing, all we can do is just throw this file out to the machining process and it will be made. However, there's a big process behind how we came to know, or how we came to design this particular part. Okay, and there's also a part B or part A, the counter version of this file that exists. If you were to change this file here, so for example, if I were to say that is a different number, automatically that will remodel itself. So I was trying to show you that by leaving both of them on the screen. So I'm going to go into equations. I'm going to go manage equation, and instead of that 150, if I were to go 200 and try and keep an eye on this file here, hopefully it will automatically change when so that's morphed. So if I click onto this window now, it will rebuild itself to reflect the changes. So there is a live connection between both of these files. Look at that. It's updated and it's made the changes. I'm pretty happy with this approach now. What I would like to do is, well, it would have been quite nice to have some fillets around here, but that ruins the purpose. They look, yeah, this looks good. I like this. I like this. Look at that. So they are connected, they remain connected, and I don't need to worry about them meshing together, because part A and part B will always mesh together because they come from the same master file, and these are the derived files. Look at that. Hope you like it. See you for the next session.